Hey everyone, welcome to my channel. Today we're going to learn about essential cloud computing and storage knowledge. And if you're new to cloud or you want to learn you to become a DevOps engineer or a cloud engineer in general, this is a must know session or must learn session. Watch till the end. This is going to be very important. Okay, and I think already your viewers are live. Without any further waiting, we're going to get started. Okay, so today, of course, you know that today is about essential cloud computing and storage session. And first thing, we're going to learn about cloud computing. So suppose anyone say to you like cloud computing for in general. So what exactly is a cloud computing? You have to tell them. Even in interview, they ask you what exactly is a cloud computing, right? So what does cloud computing really mean? So cloud computing mean that the word compute means object related to software computation. So if you ever think about the word someone saying compute, think it's about computer, it's about processing or maybe something related to computers in general, okay, or software computation. Now it's more of a generic term and that refer to processing power, memory, network, or any other resources such as storage, could be anything else. So anything related to software computation is compute. Think in your mind, okay? So now suppose anyone asks you in an interview, what exactly is compute? You can say it could be processing power, it could be memory, it could be networking, anything that is required to get something, some computational work or some computer processing to be done. Anything, okay? That's the word compute really means. Now, if you think that way, then what does the cloud computing mean? So cloud computing again is a generic term for anything that involves delivering computer resources over the internet, okay? And user can access large amount of computing power and demand. Of course, you can scale up to infinite if you really want, if you have the budget, to be honest. So you can hire as much as computing resources. What are the computing resources again? Could be CPU, could be RAM, could be networking, could be anything else that's related to computing. So you can hire anything. So they can purchase by minute. So you can purchase computing power or the compute things by minute, hour, like as much as you want or as little as you want. So if you have lower requirement, of course, simply go with the low, like say you need only one CPU and 1 GB RAM. Of course, go with that. Even if you go below that, that is also possible. Suppose you need 8 GB or 10 GB RAM. Suppose you need 2 CPU, 4 CPU, 8 CPU, whatever processing or whatever compute power or storage you need, you will get it via cloud. Okay. So now that's more of a bookish term. If you ask me how I think as a compute, so think about your local computer. You do different kind of editing, you do drawing, you do document processing, like writing Word and all that. You do PDF and all. So you do a lot of steps, isn't it? Now to do that, you need computing power or your local laptop. Now in local laptop, what you have? In local laptop, you have your CPU. Like if you go to market, you see the specification, right? You need i7 or i9 or such kind of CPU, right? Then you need a RAM so that CPU can, whenever it need like random data or fast data, that RAM provide, right? RAM is the memory stored of the CPU processing and other things, other cases also there. But think of RAM is needed for CPU to process data fast, okay? So then you have the RAM, then you have the hard disks where you store data for longer term, could be months, could be years, like as much as you want. Then you need other things like motherboard and everything, right? So all thing combined is compute. So next time if anyone asks, this is not a rocket science. Compute means think of the local computer. Now think of cloud computing as somewhere else the computer exists in remotely. Maybe you are in India right now, or maybe you are in say Bangladesh or Nepal, anywhere, and you are accessing a computer maybe another place. Maybe I'm in Kolkata, I'm accessing in Mumbai, I'm in Kolkata, I'm accessing in US. You can remotely access those computing resources. That's what exactly cloud computing means in layman term or in some normal term, okay? So cloud computing is just means that you are hiring some cloud remote cloud computing resources. It's lying somewhere else, mostly data centers, okay? So that's the easiest way to understand cloud computing, what it is. Now next, now, like, what are the computing resources then? I mean, I already said it. But just so you know what are the computing resources mean, that it means CPU, RAM and everything, as I told you. But if you think about the cloud computing point of view, what you mostly need, okay, if you just go to any cloud service provider, uh, like, then you have this kind of things, right? Mainly you have a selection of the CPU and RAM. So how much CPU you need, how much RAM you need. Mostly you look at that. Of course, you look at network and other things, but the more important part here is come to this CPU and RAM. Okay, because your application mostly depends on that. That's why. Now, if you see that cloud computing, let me just quickly have it here. Okay, so cloud computing resources are measurable in quantities of computing power that can be requested, allocated, consumed for computing activities, and below are the main computing resources. Of course, I'll come to that. Now, this is again more bookish term. What does really mean? It really means that your computer, your application, what you're supposed to run in your computer or maybe in cloud, you know exactly how much CPU it might need because you're running it, you know, you can see it, observe it. And you also know how much RAM you need. Okay, so you know how much you need and you can measure it and you can ask or request the same thing from the cloud service provider and they're giving you exactly that. Of course, in like there is the cost involvement is and everything, we'll come to that, but you can get it what you want. Okay, now CPU and RAM I think you guys already know, but just to as a reminder of all that. So a CPU or central processing unit is kind of a brain to any computer. Okay, and CPU is measured in unit called millicores, and application developers can specify how much how much allocated CPU are required for running the application and process data. Like you know already how much CPU you need. Okay, now next up is the RAM. Now RAM or random access memory computers short-term memory where the data that the processor is currently using is stored. So your processor is processing something, right? That data, the random or quick data like CPU need immediately, that is actually stored in RAM. Okay, and and your computer can access RAM much faster than any like hard disks or short-term or SSD, those kind of devices. And for other any long-term devices, say even portable hard disks, those kind of things they're referring. Now, which is why RAM capacity is critical for system performance. So, how much CPU or how quick can CPU perform? Of course, this based on the CPU's performance. Also, it also depends on how much RAM you have. So, if you have bigger space, then the CPU can use more such memory on process things faster. That's why the RAM also required. So, anything, suppose you're running an application. So that application actually running in the CPU processing it and is running on the memory. So it's storing the data on the memory. Okay, that's what this means. Okay, now let's come to the next one. So okay, so we are going to a bit more deep dive into about more computing for the cloud. Okay, and we'll go a bit more deep. Now, while if you go to any cloud service provider, the first thing they will you will see is like before you go and start a like a remote computer or remote instance, you need to specify the VM. Now let's understand exactly what is VM. Okay, and this is very crucial. So what exactly is a VM or virtual machine? So VM or virtual machine is virtualization or emulation of a computer system, and it function exactly same as your like a virtual computer system with its own CPU, memory, network interface, storage interface. Okay, like normally you can have in like normal physical hardware system. So, and virtual machines are basic building blocks that get computing power from the cloud. It definition as per the different cloud service provider. We'll come to that. But again, in a normal term, what exactly is a virtual computer? So if you have a normal laptop, it have the CPU, it have the RAM, it have the network, so you can access internet and all that. Think exactly same thing, which kind of a digital representation or a remote. It's a digital representation or kind of a digital copy of your physical computer. So in remote computers or virtual machines, what you can do all the stuff. You can do, I mean, you have the CPU and you have RAM and you have storage, so you can run your application, you can download things, you can upload things, you can do access internet from the remote computer as well. So you can do whatever you can normally do in a normal computer, you can do exact same things in the virtual machine. Okay, and different cloud service provider have different definition, but you will understand they're meaning the exact same thing. So let's come. So what does Google Cloud saying about the virtual machine? So virtual machine or VM is a digital version of a physical computer, right? Whatever I'm saying, they are saying the exact same thing. It is a virtualized instance of a computer that can perform almost all the function as a computer or a normal physical computer, including running application and operating system. So in virtual computers, you can do exact same things like editing a Photoshop, you are editing a file, you are writing code. You can do exact same thing in a virtual computer as well, and we do as well. Okay, so as per Google, it's a digital version of a physical computer, and that what it actually it is. Okay, what AWS saying? So AWS saying a virtual machine is a software. That will come to that. Why is calling the software? We'll come to that up next slide. So a virtual machine is a software that can perform all the same function as a physical computer. Okay, including running application, operating systems, and it is a digital version of a physical computer. They are saying the exact same stuff what Google Cloud was saying, right? And virtual machine can run programs and operating system, store data, connect to networks, conduct other computing functions. They also require maintenance and updates and system monitoring. So if you're saying that a virtual computer or virtual machine is a digital representation of a normal physical machine. So normal physical machines, I mean a normal computer, you do like system updates, you do normal system patching, upgradation, OS upgradation, new software installation, removing the obsolete software. We can do, or we will do normally in case of virtual computers, exact same thing. So coming to the same fact, it's simply a digital version of a physical computer. Normally physical computer what? Tangibles. You can touch your laptop and all that. Of course this virtual computer you cannot, it doesn't have a physical things. Of course that is mean virtual. And but it also function exact same thing, like you can assign CPUs to the virtual computer, virtual machine. You can assign RAM as much as you need to virtual machine. You can do all the stuff, and your application will perform as per the limit you are setting for the virtual machines. Okay. So what Microsoft Azure is saying about the virtual machine? So a virtual machine, commonly shortened as just VM, is no different than a physical computer like laptop, smartphone or a server. It has CPU, it has memory, disk to store your files, and can connect to internet if needed, just like your normal computer. And while the parts that make up the computer called hardware and are physical and tangible, VMs are often thought as virtual computer or software defined computers. I'll come to that why it's calling software defined computer in the next slide. So software defined computers within physical server existing only as code. So ultimately what happening? There are certain software running which making this virtualization possible. That's why as we were saying, it's simple, it's only exists on the code making that possible. We'll come to that now. Okay. So we understand what is a virtual machine, but how does the VM really works? That is also very important, isn't it? So how it works? So virtualization technology enable us to use virtual machines or VMs. Virtualization uses softwares to simulate virtual hardware that allows multiple VMs to run a single machine. So there are certain software running which enabling us to achieve this virtualization of computers. Okay, and we can run multiple virtual machines on a single hardware, a single physical machine. So suppose you have a laptop, you can run like multiple virtual machine as much as you have the physical limit. You can divide that computing resources to this virtual machine. You can run that way. Okay, that's all that means. And a physical machine is known as the host, while the VMs running are called guest. So suppose you're running virtual machines inside your own laptop. Just assume that way. That means your laptop is the host and the virtual machine are a guest. Okay, and this process is managed by a software called hypervisor. And you might have heard or might not have heard about the hypervisor, that this is very critical to achieve this virtualization. So let's learn about, or let's understand what exactly is the hypervisor. So the virtualization process is managed by a software known as a hypervisor. The hypervisor manages the hardware, it separates the physical resources from the virtual environments. And so what exactly is meaning that it's a software that help you achieve this hardware virtualization. Okay, and it also manages all these virtual environments as well. Now, the hypervisor is also responsible for managing and provisioning the resources like processor, memory, networking, storage, and all other computing resources. This hypervisor can manage them really well. And now, like again, processor, networking, storage from the host to guest. So these guest systems or guest OS, whatever we call it, hypervisor managing all, like how much, like you have say 5 virtual machine running in a single host. So which machine should get how much RAM and how much CPU? That a hyper you can define, or hypervisor define that. Like you can define by hypervisor. That means hypervisor is defining all that, right? Now it also schedules operations in VMs so that they don't overrun each other. Okay, and other when using different resources. Also, if user or program require additional resources, hypervisors schedule the request to the physical computer resources, so the virtual machine's operating system and application can access the shared pool of physical resources. See, if you have say 10 virtual machines, okay, and your computer or wherever you're running the application of hypervisor, that has like say 10 GB. You have 10 machines, you have 10 GB. So each one machine, right? That hypervisor makes sure that if you have set limitation, it should not go overrun. Now suppose you have 20 GB, okay, and 1 GB running in each virtual machine. You have 10 VMs, and each VM have 1 GB. One particular VM requires more kind of like CPU and RAM, that kind of thing. So then this hypervisor, like the guest user request to hypervisor, and hypervisor will again check if it has the physical, the physical resources, and it will simply assign that to the guest OS which require it. Okay, so hypervisor manages all. Now and now the types of hypervisor. So there is two kind of hypervisor available. Type 1, which we call it bare metal. So what does the bare metal means? So a bare metal, you don't have operating system, you don't have additional software installed. It's kind of normal computer you get from the market. Think that way, okay? And these VMs, VM interact directly with the host to allocate hardware resources without any extra software layer in between. And KVM is an example of a type 1 hypervisor, and KVM has merged into Linux from kernel in 2007. So if you are using a modern version of Linux, of course you already have this KVM installed. Okay. Now this bare, I think you must have heard bare metal, and you might have confused like what these guys are talking about. What is bare metal? So bare metal nothing but a empty box, you can say, where you have the every computing parts, but it doesn't have any application or operating system installed. VMs can directly get the resource as much as possible via hypervisor. Okay, and then we have the type 2. So what is this type 2? Now the type 2 hypervisor is a hosted one, and it runs on the host computer operating system. Hosted hypervisor pass VM request to the operating system, the host operating system, which then provision the appropriate physical resource to the each guest. So what does the type 2 VM meaning? That the normal cases type are not happening. You have your hardware like CPU, RAM, and all the resources. Above that you have hypervisor software, and hypervisor directly interacting with the physical resources. Now if you see the image here, I think on top, then the type 2 hypervisor, you have the hardware, the physical things, CPU, physical RAMs and all that. Then you have operating system installed like in your local laptop. you have like your all the stuffs, the CPU and everything is set up there, and then you have operating system, maybe Windows running or Linux running or Mac OS running, whatever is running. There you have operating system, then you're installing your hypervisor software, then that hypervisor is provisioning the virtual machines. Okay, so that is a type 2 hypervisor which exists like where it's installed in an operating system. Okay, and now what is the main differences if someone asks you like should you use bare metal or should you use the hypervisor which is hosted, is around managing stuff. Most cases if you use a type 2 hypervisor, then there is OS is managing the hypervisor, you have more of UI and like you have a lot of extra features, where of course in the bare metal you can, in the hypervisor that you are using, that might have all the features, but there is no intermediary. Like in the type 2 the intermediary is what, the operating system, but in type 1 the hypervisor directly interacting with the hardware, physical hardware, so it has no intermediary. That's the main difference. See, suppose if someone asks you about what to use, again it will come to like the cost, how much, like most cases type 2 hypervisor cost less, like type 2 entire system costs less, and type 1 is simply that you are directly getting access to the physical hardware, that cost will be higher if you think about the cloud perspective. Okay, so bare metal means no operating system, nothing installed, it's just your bare physical resources, and you're like using how much you require for your virtual machines. In type 2 you have operating system already installed on the host, and that is like helping the hypervisor to provision thing from the hardware resources. Okay, that's the main difference. I hope you have some understanding of the hypervisor. So if suppose someone asks you in interview what exactly hypervisor, we can say hypervisor is software that allow us to achieve this virtualization and help us to run virtual machine. That all you have to say, that will be more than enough. Okay, now this is another very important. So why VMs are actually required for the cloud? So you can go with the bookish one, but I want to explain this in a more simple way. Okay, so see, if you have single physical computer, say your local laptop, okay, you have suppose 8 GB RAM, suppose you have say 4 CPUs or 8 CPU, how much CPU, whatever it is you have. Okay, now you are running your operating system that might be all the time using one CPU. I mean, this is also too much, but suppose it's using one CPU and you're running one application, it's using another CPU and maybe 1 GB of RAM. Still you have so much unused resources. You have maybe 4 CPU or say 2 more CPU remaining, you might have so much memory remaining, you might have so much of storage remaining. What happening? That is a wastage, right? Now think about, it's a wastage in your local computer. Okay, think about, for cloud computing companies or cloud service providers, they have data centers like a building with thousands of machines like CPUs, RAMs and all the stuff. If they don't do virtualization, that means if suppose there is no virtualization, you simply had one physical computer for them, it's physical things, then one application, one OS running and some application running, it still have so much resources which is not getting used. That's a wastage. Okay, and of course there is too many machines, that means like they have to manage the heating of the machines, they have to manage a space of the machine, a lot of stuff, right? So that actually can be avoided if in a single machine, like we can run multiple virtual machines, and then one customer comes, we assign one virtual machine, another customer comes, based on his requirement we might create the virtual machine and give the virtual machine to the particular user. That way it's fully utilizing one physical hardware resources. That is the main requirement or main reason why these cloud computing companies or cloud in general require the virtual machine. And not just that, there are other features as well. So let's go with the definition ones, or why the cloud does in a more you can say normal term. So server constellation, that is the server resources sharing with multiple users and application, is the top reason to use VMs for cloud service provider, as most operating system and install a running application use a small amount of physical memory or resources, and when deployed to bare metal. Okay, bare metal which you didn't had all this previously installed, it's maybe freshly installed OS, freshly installed application or freshly running applications. Okay, and we can now with virtualization servers we can place many virtual server into each physical servers to improve the hardware utilization, cost, space, cooling of the data center. That's the main reason, as I say. Okay. Now VMs are, again, just repeating myself, but again I'm like repeating the one word. VMs are the basic building blocks of virtualized computing resources and play a primary role in creating application tool environment for virtual machine online on premise. So simply say, like, there are many benefits, right? Main cases, you suppose have one, you required one virtual machine, maybe one CPU or say two CPU or say 4 GB of RAM. Suddenly there is a spike, okay, and you need more resources. You can quickly spin another virtual machine, like maybe in the same host, maybe in other hosts, wherever available, and it's virtual. It will be much faster. If you normally require, suppose you're a data center, unless you're a data center, you are normal, you're running application, your hardware, your computer is full, it cannot run anymore. You go to market, purchase or buy a new machine. That's a lot of headache, lot of thing, a lot of money involvement is required. But what if the virtual machines, you need new virtual machine, you go to cloud and say, I need more, just I require urgently, will quickly get it. And if you don't need it, you can discard it. You can just terminate the virtual instance. That way you can save cost as well, right? Now, a virtual machine may run on many underlying physical machines, giving application computing power required to run successfully, or required to run application successfully. Okay, and cloud computing gives users the ability to deploy and scale virtual machines on demand. Just like I told you, if you need more, you can have more. If you require less, you don't want the extra computing power, you can just terminate the extra computing resources. Okay, it offers guaranteed computational resources in secure and isolated environments, and without the overhead of required to manage all the physical servers. So physical server, if you buy new resources, you have to manage, but here you are not managing that much, right? And just below that I have mentioned the common use cases. One is this separate development and test environments. So VMs can serve as isolated environment for testing, development, and include full functionality, but have no impact in surrounding infrastructure. That all that means that if you need one machine or one virtual machine for like staging, one you can need one for testing, one need for production, we need multiple production, and they can have like, all this kind of separate environment can spin quickly using virtual machines, right? Now, boost DevOps. So a VM can easily be turned off, migrated, adapted, scale, and provision maximum flexibility you have for development, and in production scale up when needed. So in production, what happens? You suppose you're running 4 instances, okay, small application. Suddenly you are running some offers. For any reason, you need more computational power. If you have, you're running on a virtual machine. If you need more, you can quickly spin up. Okay, you can even set automatic ruling that I have for running, I can maximum, like this is called auto scaling. So I need say maximum up to 10, 20. So based on the usage, based on the request, or based on the workload, you can increase it up to that much. And if you don't have that much of things going on, it will scale down that way. Okay. Now the second one, third one is disaster recovery and business continuity. So replicating system in cloud environments using VM can provide an extra layer of security and certainty. Cloud environments can also continuously get updated. So what it is meaning that, suppose you in one VM or you are doing something, you are maybe doing some work, very important documents are there, you can quickly create multiple backups in multiple virtual machine if it's required, if it's that critical. Okay, and even if one virtual machines somehow corrupted or not working, you still have other copies. So that works as very good use case for managing backups and disaster recovery situation also. Suppose in one region your running got down for any reason, maybe out like some misconfiguration problem, you have other regions where you can run the virtual machines. So that is kind of assurance. Okay. Then we have enable workload migration. So the flexibility and the portability that VM. So ultimately VM is what? Virtual machine, right? Where you can create virtual images and you can quickly migrate from one place to one VM. Like if you want to migrate data or anything from one VM to other VM, it's very easy. Okay. And of course, the flexibility and the portability that VMs provide are key to increasing the velocity of migration initiative. Suppose you want to migrate, you're more flexible to migrate very quickly. Okay, create a hybrid environment. So VMs provide a foundation of creating a cloud environment alongside an on-premise or one, bringing flexibility without abandoning legacy system. So ultimately, what happens? You go for the migration cases, right? And when that happens, you want to make sure your old system exists, and your like while migrating to cloud you have this VM, so you can quickly migrate. Even you can run virtualization in on-premise as well, and you can do lift and shift. That kind of flexibility you have. Okay, now let's go to the next one. Now this is very important, but before that let me see if any questions coming or not. I'll quickly answer, otherwise I will just simply continue. Okay, so let's see. Okay, so not like if you guys have question, keep asking, I will definitely cover. Okay, now so types of virtual machine with ref to top cloud provider, and this is very important. Okay, and listen to very carefully this part. So there are different application project have different computing requirements, and based on the requirement we have like selected VM types. Okay, you can see it below. Now what are the types of virtual machines you have? You have general purpose. So general purpose instances provide a balance of compute, memory, networking resources, and can be used for a variety of diverse workloads. And these instances are ideal for running application that uses these resources in equal proportion, such as web server, code repositories. For example, you are running small or medium applications. Those cases you can run these general purpose instances, like maybe even it's like general purpose, but if you need more scalability, you can run multiple copy of this general purpose instances. So where you have small to moderate workload, on those cases you should go for the general purpose. Now what are the general purpose instances you have? For Amazon EC2 we have A level instances, M, T level instances, and Mac. Okay, for Azure you have B, D level, and D level instances. For GCP you have E level instances and N level instances, like E2, N2, N2D, N1. Okay, and again if someone asks you like why you should use general purpose instances, like purpose is like the name defining itself is general purpose. So when you want to run small application, medium application, you want to run small processing, those cases like running web server, running Node.js server, Python server, it doesn't have very huge workload, or maybe you are not doing very much of processing things, those kind of cases is a very good use case to use general purpose instances. Okay, now what is the next one? Is the compute optimized. Now what is a compute optimized instances? So a compute optimized instances are ideal for compute bound application and that benefit from high performance processor. Like, listen to that word very carefully. That compute bound application that benefit from the high performance processor. If your application have a requirement to use high capable processor or more processing powers, then only you go for the compute optimized processor. Okay, of course compute optimized processor cost a bit more than a general purpose computer, okay, or general purpose instance or virtual machines. Okay, and and instances belong to this family are well suited for batch processing workloads, for media transcoding, for high performance web server. So of course if you have web server that this processing a very huge traffic, doing a lot of stuff, multiple things you are doing, that might require more CPU power, that justifies that it require more CPU power, then you go for the compute optimized instances. And of course high performance computing, scientific modeling, dedicated gaming server and ad server engines, machine learning kind of models making those kind of cases, or other compute intensive. So if you are doing any kind of processing or CPU processing where you need that much of very powerful CPU or multiple CPUs, or like kind of more of CPU processing power, you need more optimized CPU, then you use the compute optimized instances. Okay, and examples are, if you think about the cloud way, or if you go to any cloud, then you have the AWS C level instances like C4, C5, C5a, GN, Azure instances. You have FS, FSRV, and suppose GCP, you have the C2. Okay, so these are the more compute intensive. Okay, now the next one is the memory optimized. So what is memory optimized instances? So memory optimized instances or virtual machines are designed to deliver fast performance for workload that processing large data set in the memory. Okay, so what does it really actually mean? It means if you are doing more of a processing in memory, so if your application, like running application, require more of the memory or RAM, those cases you should go for the memory optimized instances. Now what are the use cases? Suppose you're running cache server. Okay, now what does the cache server actually do? They store the data or the most frequent data in the memory so that it can be accessed very quickly and there is less time to process anything, like it's already available in memory, like elastic cache for example, or redis cache or mem cache. Those cache engines require like all the data to be stored in the memory so that it can be accessed very fast. Those cases it's make sense to use the memory optimized instances. Now in AWS EC2 we have R5, like R level instances, we have X level instances, we have Z level instances like Z1D. For Azure virtual machines you have E level instances and M level and D level instances. For the GCP you have M1 and M2. Now you don't have to actually remember all this type of instances, just keeping in mind that you have this kind of instance. This document can work as a reference, I may share it later on, there you can find it. Okay, then come to the storage optimized instances. Now what are the storage optimized instances? Storage optimized instances are designed for workload that require high sequential read and write access to very large data set, or on local storage. Okay, and they are optimized to deliver tens of thousands of low latency random IO operation per second or IOPs to application. Now what does that really means? It simply means if in a say in a drive you are doing too much read write request, if you are you need it to be very fast, as fast as possible, the IOPS, the read write performance has to be peak. Those kind of cases in is storage optimized. It could be database servers where you are where is actually you are storing the data, retrieving data, then it matters as much as or as fast as possible you want the data to be retrieved or written. Those cases storage optimized instances make sense. Okay, and AWS have D2, D3 and H, I, those instances. For Azure you have LS, V2. For GCP you don't have any, unfortunately. Okay, now for accelerated compute and high performance. So what are those? So accelerated computing instances use hardware acceleration or coprocessors to perform function such as floating point number calculation, graphic processing or data pattern matching more efficient than is possible for software running on CPUs. Now, high performance computing HPC instances are purpose built to offer best price performance for running HPC workload at scale. Now, all that's meaning if you have requirement to run very high CPU processing workload, just for example, like match day for example, in a Hotstar, if you need like many people watching it, there is transcoding going on, there's a lot of things going on, right? So those cases it makes sense to use this kind of big instances. There are millions of you watching, there is processing going on, there are a lot of things going on. It's very hard for normal instances or general purpose instances to manage all this workload. Then it makes sense to use accelerated computing. Or maybe you are doing a lot of graphics processing, for example, you're running maybe some transcoding, or maybe you are like maybe doing graphics, we run machine modeling, right? Those cases also make sense to use accelerated compute. Now if you ask me like what is the difference between this memory and storage optimized, so memory means the RAM. Okay, RAM means what? Random access memory, which CPU store data most cases to quickly do process the things or when your application running is run on the memory, right? Now that's the short term storage. If you reboot it, it's gone, or if you don't have it, if there is garbage collector going on, the garbage collected, your RAM get freed. Okay, but storage optimized, storage is what? It's a long term storage you're talking about, where you have a lot of data you need to store somewhere, you need to store very fast, write very fast and retrieve very fast. It's a different use case, that's why. If anyone have any questions, feel free to ask, I'll definitely cover. Okay, Now let's go to the next one. Now this is very important concept here. So what is a virtual CPU? So the moment you go and choose a different kind of virtual machine for any cloud service provider, there you have to select like how much CPU I need. You have to select that, and the option you get is a virtual CPU, not a physical CPU, of course. So what does a virtual CPU means? A virtual CPU or vCPU stand for Virtual Central Processing Unit, and a vCPU represent a portion or share of underlying physical CPU that is assigned to a particular virtual machine. So if you think about virtual CPU, so to a virtual machine, how much CPU is assigned is actually the virtual CPU. That in simple word. Okay. Now let's go a bit more deep into it. Okay. So to understand it more, let's understand this concept first. Okay. Now I will all the next question I will come at the very end of this session. I will cover all the courses. I'll keep asking. That's fine. So now let's understand the concept of thread. Okay, a thread is a path of execution within a process. A process contains one or more threads. Now, what is the difference between this thread and a process? The primary difference is that the thread within the same process run in shared memory space, while the process run in separate memory. The process is actually run as separate memory spaces itself. Now, to simplify even further, CPU run multiple processes. So we are running multiple things, maybe Node, Python, maybe other XYZ application. Every single application have its own processes, and every single process might have two or like one or more threads, which might be doing a lot of stuffs. Okay, suppose for example you are running a what. Okay, or maybe another good example. Suppose you are running a Chrome tab. There, what happens? You have a window where you have multiple tabs, for example. So window is a process, and window tabs are threads, for example, where you do browse a lot of other stuff. So that's how things are working. So a thread is where you have multiple things running under a process, and process is managing, like in a process there is shared memory. These threads are using like that memory between them only, but it's under one processor. And you can have multiple processes running, and under multiple process you have multiple threads. That's the main difference between this. The one question is that you don't have to remember all these VMs. No, you don't have to. Just remember that what are the type of virtual instance you have. That's only. So yeah, now you understand the thread part. That thread is more of when you're running one process or your application or anything. There is a process going on, and that process you are like have multiple threads. Okay. Now, a thread is also known as a lightweight process, kind of sub process. Okay. The concept of parallelism is to divide a process into multiple threads. So a process can run a lot of stuff, and thread is parallelly computing all the stuff. Okay. And as example, this is the example of like if you have opened a browser window, you have multiple tabs, and that means the main process is the window, and other tabs are the sub threads. Okay, or sub processes. Okay. Now we understand the thread now. What the thread is. Now let's understand the physical code. So if you go to a market and buy a CPU, that physical thing that you can touch, you see the processor, there is the dots and all the stuff there. If you have ever seen a CPU, so a physical code is also referred to have the as a processing unit within the CPU, and a single physical core can correspond to one or more logical cores. What that is mean actually? If you ever seen a CPU, you might see one chip or two chip, whatever the CPU is programmed like, but logically there might be multiple cores are there. Maybe you heard about like dual core, so two core. Say i3 have 3 core, i7 can have multiple cores, i9 have even more core. So even you see on a physical perspective, the CPU can have multiple cores, and multiple cores mean can process multiple stuff. One core can handle a lot of more other stuff. Okay, so more, that's why in general also that means more CPU core mean it can do processing more in fast way. Okay, let's come to the logical core part that we just talked about. A logical core makes it possible for a single physical core. Okay, so a logical core makes it possible for a single physical to perform two or more actions simultaneously, like parallel way. And newer cores are like a full-fledged CPUs. So they are capable of working on multiple tasks simultaneously. However, they are not true CPUs as physical cores are. There are limitations to hyper-threading physical versus the physical capabilities of the core. So yeah, even though we are saying it's virtual cores, I mean, of course, one physical is can have multiple virtual cores. Okay, so of course that's a fundamental difference is there. But think of that, if your CPU has multiple cores and this core is actually defined by the manufacturer, we cannot define that. A manufacturer who is manufacturing the CPU can define how much code the CPU can have. We can buy it, that's it. So there you can understand, okay, I have this kind of CPU, it has multiple core, it will perform better. Okay, now let's understand how this virtual CPU works. So hypervisor, now you understand what is a hypervisor, that enable like that create the virtual environment and help us run the virtual machines, that is hypervisor. Now the hypervisor controls the virtual machines and their resources, their resources uses to a portion of the physical CPU. So a hypervisor say out of this physical CPU, this much XYZ amount of CPU processing power this virtual machine can use. That's all a hypervisor do. And so a virtual machine, how much CPU it can use, that represent that virtual machine's virtual CPU. So one virtual machine have two CPU core, say two virtual CPU. That means it have the two virtual CPUs. Okay, you have to make that in your mind. Now there is a particular computation, or there is a way to understand how to calculate this virtual CPU itself. So how to calculate a virtual CPU? See down below there is a calculation. So a simple formula. The formula is threads. So one CPU core can perform can have multiple threads. Like one process can have multiple threads. Okay. So threads mean one process can how much thread, and so threads into cores into physical CPU. Now for example, you have one CPU that has 8 cores. Just imagine you have one CPU that had 8 cores and can run a 16 threads, for example. That means how much CPU you can have. So you have 16 threads because 16 threads and you have 8 cores. So 8 into 16 into 1. Suppose you have say 2 core, then 6, and that have suppose similar 8 cores and 16 thread it can run. So that means it can run 16 into 8 into 2. So this is one formula that you might have to remember, take a note of it. So suppose someone say you I have this amount of virtual CPU. So you can then back calculate like what is the physical which is the real equivalent of the physical CPU. That is very helpful for that. Okay. So now you understand virtual CPU is the CPU that is assigned to a virtual instance or virtual machine, that is virtual CPU. Okay. Now let's go to next one. So yeah, I think this one is very very important. If you go to any cloud service provider, for example, they will tell you like you have two choices most cases. So if you select a VM or any OS, for example, you see a Ubuntu virtual machine you want to go, then you will see two choices. One is the ARM processor and another is the 86 processor. What these processors are, we'll learn about them in next slide. But for now, just understand, if you see ARM processor, then you have the option to Ampere Ultra and AWS Graviton processor. Like anyone say we are running our application and in a cloud and it might be using ARM processor. So that means it might be if it's AWS using Graviton processor, if it's either GCP or in Azure, they are running in ARM processor. That means the processor is Ampere Ultra. Okay. Now, what are the next processor or next CPU architecture is the 86 processor or 86 type of processor. So most cases Intel and AMD have this processor. So if you are running virtual machines, so that means that virtual machines running inside this kind of processor. That's why it's very important to know what kind of processor they are running and why. The reason we will learn in the next slide. So in 86 processor, Intel processor have Intel Xeon Scalable processor Ice Lake 3rd generation, Intel Xeon Scalable processor Cascade Lake 2nd generation, Intel Xeon Scalable processor Skylake, which is the 1st generation, Intel Xeon E7 Borewell and XYZ. So mainly remember that if we are running 86 processor and it's Intel, then that means we might be using Intel Xeon. what is the generation that you have to have an eye for, and always remember latest generation have better performance. That's why they creating new generation to performance boost, patching and all that. So always better to use new generation CPUs. Okay. Now, what are the AMD processor you have? So AMD processor you have AMD EPYC Milan third generation and AMD EPYC Rome second generation. Okay. So if you are going to, yeah, now think very carefully. If you are going to run, create a virtual machine, that of course is virtual, but behind the scenes, like below the hypervisor, there is this kind of CPU is running. You have the selection what kind of CPU you can use. You can go for the ARM or you can go for the 86. Now, while choosing a CPU, notice that generally higher frequencies indicate better performance. So, when you select the CPUs, you will see the CPUs with most more CPU frequency like 2 gigahertz, 3 gigahertz, those kind of thing. So, the more gigahertz means more CPU processing power, more processing power. But always look at the next generation things, because sometime like this is a kind of golden rule, more more gigahertz, more frequency means it better. But what happening, latest kind of processor, sometimes there is performance tweaks, they do something to make the CPU performance better. So new models with maybe in other generation might have better performance. So you have to check the difference performance metric before choosing the what CPU kind of, like what kind of CPU you want to go for. Okay. Now we are learning about ARM processor and 86 processor. Let's learn what this actually means. Okay, so most common CPU architecture processor we have for the cloud instances. So the moment you see you are going for selecting, like when you cover the cloud part in say after like a few weeks, then we will learn more about this process selection and all that. But now understand what this actually means. So you have mainly two choices, either ARM processor, either 86 processor. Okay. So what is the meaning of, what are the ARM processor? So ARM stand for Advanced RISC Machine, and RISC stand for Reduced Instruction Set Computing. This means that the CPU that are the CPU are a limited number of instruction it can use, and as a result each instruction run in a single cycle and instruction is simpler. Okay. ARM is designed to be smaller, more energy efficient, create less heat. Okay. Okay, I think I have to ask to zoom out a little. So I hope now it's okay. Now this looks bad actually. I hope it's fine now. Okay, I did it. Okay. So now this ARM is designed to be, you understand, it's smaller, more energy efficient, creates less heat, and this make it's perfect for mobile devices like smartphones, like the small size makes it great for the tiny devices. The energy efficiency gives the device a longer battery life. The lower heat is a good for that device constantly being held. Now, what does it really means? Okay, it means where you cannot have bigger CPUs, okay, and there is simpler instructions, like it doesn't do very complicated stuff. Those cases ARM processors are very good choices because it's have limited capacity, it's understand the simple instruction set. Okay, and good use cases are like CPU like this smartphones and all, where you have like the space is smaller and it should not create more heat because it's doing a lot of stuff these days, right? It's getting more heat, the phone become overheated, and you can see the small atomic bombs bursting for Samsung few years back. So you don't want that to be happen. So that's why ARM processors are designed or equipped to be like that, small, bit less. I will not say small because you have M2 engines, like it's a revolution to the computing world. It's also ARM processor but very much computing power. But before that, just rule out this apple part for now. Think that ARM processors were designed to be doing smaller stuff, like say you have a coffee machine, you have limited buttons. Okay, there might be an ARM processor running where you give like, I need latte coffee, I need mocha coffee, and it do the stuff, right? There it is a smaller processor. Those cases ARM processors are very good choices. Now ARM processors are a bit more powerful, like Apple M1 M2, all those kind of massive stuff. But normal cases are ARM processor. You see normal cloud instances and like are designed to be running small stuff. Okay, you should not run very much complicated processing things there. Now let's come to the 86 processor. So 86 is like 86 generation of processor is the most widely used instruction set on PCs. So if you see PCs, laptops, big machines, there it might be using a 86 generation processors. Okay, and with this like the most one in the history as well. Like most of the computers right now have the 86 processor. If you exclude the mobile phones, like mobile phone have the ARM processor, right? Like as I say, mobile phone and tablets have the ARM processor. Like laptops, like big machines, big computing resources have the 86 processor. And with 86 processor, the complex series of operation can be executed in a single cycle. So in a single cycle, you can execute multiple complicated processing. Okay, and of course there is a trade-off. So that means if you are doing a lot of stuff, the CPU getting heated. You need a dedicated cooling. That's why in a CPU, if you see the previous times, or even now also, if you are running a CPU, I mean, in a computer, you are adding a fan to it because it need to be cooled. It's using so much complex computation and all that, right? Now, these processing units with this type of instruction are called complex instruction set computers, CISC. So ARM is stand for, I mean, had the using the instruction set for ISC, that is reduced instruction set computation, because we don't want it to be overheated and it has less processing capabilities. For 86 processor, it has more higher capability. It do more processing, complicated processing stuff, and this is under falling under the complex instruction set computer. So next time you go for, even if you see the ARM processor cost is low, that means the computation possibilities or computation power is also low. So don't just look at the low cost. If you have budget, if you want it to be your application to be more performance oriented, of course the application has to support ARM processor also, otherwise it might not even run. But we will come to those things later on when you cover the cloud. For now, understand that 86 processors are more powerful than the ARM processor in general. Okay. Now 86 CPUs that tend to have very fast computing power, and it allow for more clarity or simplicity in the in the programming and number of instruction, but it comes at expense of larger, more expensive chip with a lot of transistors and uses more energy than the ARM processor. That's why that is the fundamental thing. It has more things overloaded, and it's why it's performing faster because of more transistor, more other components. It also creates more heat. Always remember that. Note, programs written in a CPU architecture, maybe for say you are writing application for ARM architecture, that will not run for the 86 processor. And if you are programming for the 86 generation processor, thus that program that you are writing will not work for the ARM processor. This is also very important. Okay. Now, okay. Now let's move to the next one. I hope it's now visible. Okay. Yes. So yeah, we learn a lot of things about the compute. Now let's learn about the storage part. Okay. So what exactly is a cloud storage? So before even go to for the cloud storage, let's talk about the data storage first. So what is data storage? So data storage is collection and retention of a digital information, the bits and bytes behind the application, network protocol, documents, media, address book, user preferences, and more. Now, there's a bookish way. If you think more practically, you have your different document, PDF files, doc files, you have your music, you have your videos, you store that, right? So those storing process is called data storage. You have data, you're storing the data somewhere. That is data storage. Now, normal cases, what we do? We have phones. You have phone. You have this SD cards where we put all the data in the card. If you have computers, you have hard disks. So those are the storage mediums where you store the data, right? So ultimately, you are storing your data or contents in that storage places. That's we call data storage. Now, what is cloud data storage? So cloud storage is cloud computing model that enables storing of data and files on the internet through a cloud computing service provider that you access either through public internet or dedicated private network connection. What is saying? Is saying simply that you have your data, instead of storing in your local devices, in your local phone or maybe hard drive in your computer, you are storing in some remote computer or a remote place. Okay, that's what's happening behind the scene. Now, more practical approach, you have Google Cloud, you have Google Drive. What you're doing, you're uploading your file via internet and uploading in a Google Drive. That means you're uploading that to some other place or other computer. Okay, and what you're doing, you have internet, that's what's enabling you to upload and download files, right? That what is actually means. So cloud, and what happening, you are paying for the Google Cloud one. If you're storing data in Azure, Blob, or any cloud service provider, you have to pay monthly fees. So you are paying amount to store your data. That's what the cloud computing model is. And you're storing where? Via internet, you're uploading some place, maybe Google Cloud, Google Drive, or maybe other cloud service provider. So that is what, like Apple Cloud also there, where you store your files, photos, videos, right? These, like, there also, if you cross a certain limit, say 5 GB, you have to pay for more storage, right? That's what cloud computing, cloud data storage model is. Now, the provider securely store, manages, and maintains the storage servers. So of course, all this data is getting stored in some people, like some places, some computer, right? And who manage them? The cloud service provider. Suppose it's the Apple Cloud, you're storing your data. That means Apple managing. Suppose it's Google Drive, you're storing your data. Google managing it, right? And it's in a SaaS model, software service. You're using Google software, you're using Apple software to upload the browser. I mean, any browser using their site to upload the files, right? Or maybe a normal application you have Apple Cloud installed on your local computer, or maybe Google Drive, I think application you're installing in local computer, and you're uploading that, right? So all these things managed by whom? The cloud service provider, and they provide the storage server, infrastructure, network, and ensure that you have the access to these files, so you can upload and retrieve whenever you need to. Okay, and of course you have the flexibility to buy more space, you buy more, that's up to you, and you have the access of any time to access all this data. So how this cloud storage works? So cloud storage is delivered by cloud service provider, now we know all that, and that owns and operate data storage capacity by maintaining large data centers. So ultimately what happening, this cloud service provider have data centers, so it's our buildings with lot of machine, like lot of compute, like CPU, RAM, storage, hard drives. In this hard drive infrastructure, you are storing data in a hard drive, right? But of course there are all the computer running where you are uploading, there mean computer storing there, right? So ultimately what happening, you are storing, cloud service provider have like their data center, you are storing a file, that data getting stored in those cloud center or those data centers. Okay, and like they have this data center in multiple location, like for example AWS, they have data center in Kolkata, Mumbai, Chennai, I don't think maybe Hyderabad, those places, right? Similar way AWS have their data centers in Virginia, in Oregon, those kind of regions or in places. So you have those kind of data centers all over the world where your data getting stored. And cloud storage providers manage capacity, security, and durability to make data accessible to your application over the internet, pay as you go model. That's how the cloud storage works. Okay. Okay, so now what type of data storage you have available, and this is also very important. So first thing is the object storage. So what is object storage? Object storage is data storage architecture for large stores of unstructured data. Organization have to store massive growing amount of unstructured data such as photos, videos, machine learning model data, sensor data, IoT data, audio data, web content data. You can do lot of like, you have lot of data you want to store somewhere, right? That is where object storage coming, where you can store large amount of data like web content, and it has to be scalable, affordable, and quickly retrievable, right? And object storage, that's why object storage is very important, where you have to store GBs or even terabytes or petabytes of data you need to store, you go for the object storage. What are the those kind of service available to us? We have Amazon S3, Azure blob storage, and Google Cloud Storage, where you want to store that vast amount of object storage data. Okay, then we have the block storage. So we have file storage. So file storage or file storage, like file based storage or file storage is widely used for among application and stores data in a hierarchical file folder and file format. Okay, Since files are stored on backends and frontend the same way, users can request files by unique identifiers, just names. Think of in your local computer, you have files and folders, you are giving named files and folders, you have file names and all that, right? So that is a file storage. It's a file storage mechanism. You name the file, you have a particular drive, you have particular location path. That is what a file storage is. And we have different choices, I'll come to that. So there are multiple services available. Most like three common cloud service providers, say AWS and Azure and GCP. AWS gives us Amazon Elastic File Storage or EFS and FSX for Windows and Ledger. Now Azure Files, like Azure Cloud provides that Azure Files, and GCP gives us GCP File Store. So these are the cloud given file storage option we have. Now the third, and I think one of the most important one, is the block storage. So what is the block storage? So block storage splits storage volumes into individual instances known as blocks, and each block exists independently, which gives users configuration autonomy and has its own unique identifier for quick storage and retrieval. And enterprise application like databases, enterprise resource planning, or ERP systems often used or require dedicated low latency storage for each host. This is analogous for direct access storage or DAS or storage area network. In this case, you can use a cloud storage service that store data in this kind of blocks, such as Amazon Block Store, Azure Managed Disk, or GCP Persistent Disk and Solid State Disk. Now, what it simply means: think of your hard drive or SSD disk that you have in your home or in your laptop. Your OS is getting installed in this kind of block storage. Your application is running, like application code is stored in this block storage, which can be quickly retrieved, quickly executable, right? So those cases, block storage is very important, where you install OS, where you have your application set up there and you execute the files there, and then what happens? You have in your block storage a file, that file executing, you're executing and CPU executing it, and the temporary file storage happening in the RAM. That's how your application is running. So everything combined is functioning, right? Just like a normal computer when you run application, exact same happening in the cloud as well. Only difference that cloud has fast infrastructure that you can have n number of computing resources, storage, and all that. Now think of this block storage as your local hard disk or local SSD disk, okay, where you store data, quickly retrieve it, delete it, do a lot of operation, your OS is installed. That kind of storage is the block storage. Okay, that's the easiest way to remember this. Now the last one is the network attached storage or NAS. Now network attached storage makes data more accessible to internal network by installing a lightweight operating system into onto a server that turn it into something called NAS box unit or head. And NAS box becomes the important part of this intranet because it processes every single storage request. So what happened? Normally, what happened if you have a hard disk? Hard disk is set up in your computer, and your operating system, you are going, writing some files, like copying files, uploading files, deleting files, editing files, right? You're doing all that, getting stored in that disk. What if suppose you have a hard disk, and just before that you have some other tools? For example, I have this particular stuff. Okay, let me give you an example. So I have this Raspberry Pi, for example. Okay, in this Raspberry Pi I have installed a NAS software, NAS operating system. You can say that lightweight operating system is installed there, and I can attach all the hard drive here. I have already one small storage chip here, right? So now this works as a NAS device, a NAS box itself, where if I am asking, I'm saying and this is network storage, it has a Wi-Fi, or I can attach LAN cable to it, then it will be connect to my internal network. So now suppose from my local computer I want to access file what is stored like on a hard drive or maybe in this chip, I want to access to it, okay, via the IP or other means. Then if I set up username password, then this OS will validate every single time like I'm authenticating or not. Otherwise, even you make one say like retrieving request or write request, it will authenticate or it will check the storage capacity and all this stuff, then it will reply, okay, you can store or you cannot store. Those kind of things going on. So this software that or the OS that you install in this particular say small computing device or Raspberry Pi, for example, that's doing all this stuff. That's what the NAS do. You have a NAS storage which checks all the requests. Every single request is coming is like authenticated or not. It allows or not based on how the configuration you have done. That's network at a storage. So it's connected to network. It will work as a storage device. It's connected to network. So in that way, if you assume that suppose you have elastic block storage, all the computing, if you go to any VM and you have you go to for the block storage, there is like elastic block store, Azure managed disk, those kind of storage. If you want to access that thing, actually what happening, it's a kind of NAS, it's attached to network, right? That's how any virtual machines can connect to that particular storage, and you're using it. Once you're done or maybe you're terminating, it's getting quickly deleted. Just like it's also a virtual computing resource, right? So anything that is required for your computing all together, combine, that's called computing resources. So storage, your network, your RAM, your storage, everything you can be virtualized, right? So think that way. All the drives, all the block storage services that you use or you have, that is kind of a NAS device. It's connected to network, right? That's how it's getting utilized. Okay. Okay. Now some concept while choosing the cloud block storage type. So IOPs, I think it's one of the important parameter. If you go to use block storage or you want to go for any kind of service you're going to use for the storage, you will see how much IOPs you need, or it's largely related to that. Now, what exactly is IOPs? So IOPs or or output operation per second, which is called IOPS, is an input output or read write performance measurement used to categorize computer storage devices like hard disk drive, storage drive, or storage area network, for example. Now, what exactly is meaning? It's saying how fast you can do read write in your hard drives, maybe SSD, maybe hard disk, those kind of things. How fast you can copy things, more simpler way. How fast you can copy things from there, and how fast you can paste things here. Like read write, that's way you can understand that. So IOPS define that. So in a device, how fast you can do the read write operation, or in computing language, it's input output. In more user centric language, it's more of a read write happening. How fast it can happen. So IOPS is the one. Like in a second, how much you can read write. Okay. Now this IOPS matters very importantly when you have one application. Suppose you are running one application, Node.js, Python, could be any application or any application generally. It's processing things. It's doing some data processing. It might be storing some data to you. If you have a database installed in this kind of say block storage devices, so it's doing some read write from the table. So it ultimately writing some files, retrieving some files. That how fast it can get the result or how fast it can complete the write operation depends on this IOPS. That's why the more IOPS you have, the application itself can go faster, because everything happening fast, read write and every single thing happening faster, right? So IOPS is a biggest parameter for those cases, read write operations. Okay. So if you go to any cloud service provider and you choose elastic block storage, any kind of block storage, there you have the choice. Do you want normal IOPS? So based on the amount of storage you used, you can kind of like what kind of how much IOPS I can you need, you can define, or you can use provision IOPS, which will be costly. So in general also the more IOPS, that means the more cost you have to pay. The less IOPS, the less cost you have to pay. So that's also very important as a cost parameter as well. Okay. Now one question is that block storage SSD or HDD? Actually both are block storage. Now all things, three things you see here, all are block storage, because now it depends on the device type, but in general everything is a block storage. You have individual blocks where you store data and retrieve data. Okay. Now let's understand the solid state drive volumes. Solid state drive, which is SSD volumes. So normally if you go to cloud and you go for selecting the block storage, you have two options. Either you can select solid state drive or you can select the hard disk drive. Now what are the difference and all that, will come to that as well. First let's understand the solid state drive. So SSD drives or SSD bag volumes are optimized for transactional workloads involving frequent read-write operation with small IO size, where the dominant performance attribute is IOPs. So you need the read and write has to be have super fast. Then you need SSD, which help you to achieve that. And SSD is significantly faster and has more predictable performance than hard disks or HDD. Cost is also high for the SSD disk. You have to remember that one. Of course, the performance faster, IOPS faster. That's what I say. IOPS is a cost parameter. The more IOPS you need, the more you have to pay. You have to go for SSD kind of disk. Or if you want more, you can add more provisional IOPS, but that will again cost you extra. Now, what are the hard disk type option you or the HDD volumes you have? I mean, what does means? I mean, what is this SSD, HDD volume or hard disk drive? So HDD backed volume are optimized for large streaming workloads where the dominant performance attribute is the throughput, and HDD throughput is much more limited than SSD throughput. Cost is lower than SSD. What this means? You have huge volume of data, okay, and it's okay to compromise with the read write speed, but you need to store a large amount of data, okay. Then you might prefer hard disk drive where the performance of read write is slower, but the cost is also lower. So cost point of view, and if you want to store a large amount of data, you should go for the SSD. But if you need performance very fast read write, then you go for the solid state drives. That's the main difference. Both are block storage devices. The more performance you need, you have to pay more. Like SSD, you have to pay more. SSD is less costly. And again, at the very end, you have magnetic volumes. So magnetic volumes are backed by magnetic drive that are suited for workload that data is processing access very infrequently. And scenario are where low cost storage or small volume size is important. Performance is far lower than hard disks or SSD. This is where you have archive the files that you rarely access. Maybe you will access after 6 months, 8 months, or maybe you never access. But you need to store as some kind of policies you have to store the data. Those kind of cases, it makes more sense to use magnetic volumes. Again, magnetic volumes are actually getting depreciated. You should go for the hard disk volume. That also very low cost option. And if you need much high performance drives, you should go for the SSD. So now, the moment you go for a cloud service provider, you go to their page, you going for the provisioning, you should look at few parameters while choosing the virtual machine. First, you should look at the CPU architecture. Is it ARM or 86? I think you are supposed to use the 86 because it's giving you more CPU power, right? Cost you have to look at, of course. Then you have to choose what is the it is bare metal. Normal cases, it's the type 2 instance you will see, okay. Now, then you have to choose for the drive. So when after you select the CPU or virtual CPUs in general, you have to select how much RAM in virtual CPU you might need for your application to run. You select that. The next option you will get is the solid state, like what kind of drive you use, SSD or HDD volumes. Always remember, the performance of SSD drive are much better, but it will cost you more. HDD performance is lower side, but it will cost you less. Always remember that part. I think this session give you very okay. Alexa, stop. Okay, so thanks for the session. Now it's more of the QA. Any question you might have, you can ask. I will definitely answer. Now, let's go back to our first slide, for example. So, anyone have any question, feel free to ask. I will definitely answer. So one is that, can I join today a class, watch video on weekend? Yeah, see, this is live class, but it's stored in my YouTube channel. I'm not going to delete it. So you can watch later on also, that's fine. Thanks Anand. Good morning Milan. Good morning. Okay, UK is morning. Oh my god, 5:30. Let's keep up. Chirag, thank you Chirag. Difference between VM and get to use in office. See, VMs are most cases in a cloud. If you go, you have to select a VM, right? That makes more sense to go for the VMs. And you only in the cloud you will get choose the VM only. So you don't have other choices. Now, Redis cache you mentioned. Let's see what is this question. So it's Dariv saying that difference between no, not that. I think yeah, this one. Redis cache you mentioned where and how to use it. So Redis cache, suppose your application is making frequent queries for the data which is kind of same. It's rarely having any change. So maybe the data changes itself maybe after 2 weeks or 1 week or maybe one day. Okay, it's better to store the data in cache so that next time the API call require the data or you need to show some content in a site for longer time, you don't need to actually query the database every time. You can store the data in cache and you can quickly retrieve it. Okay, that's why it's stored in the memory itself. When you need it from the memory, it can get quickly. Okay, let's see. Is compute high RAM is where the memory is optimized then? So yes, if you are doing a lot of memory processing, then it's better to use the memory optimized one. That's right. And yes, Yogi is saying that we don't have to remember all this type of kind of VM type for different. No, you don't have to remember all the type of instances, but you should know that these are the type of instances, like where I should use general purpose instances like this one, for example. So these are the type of the VMs, like so where to use which kind of VM, that is important. For general purpose, suppose you have kind of normal Python application or say normal Go or any kind of web application or some processing you're doing, which is okay, is taking some minimal or maybe medium amount of virtual CPU and RAM. Those cases is better to use the general purpose. Suppose it's more of like you are running, you're doing machine model, like machine learning model you're doing, or doing lot of file processing, lot of video processing, like lot of processing stuff you're doing, where it required to use more CPU, then use compute optimize. Suppose you are doing you are doing a lot of operation in memory, so where the memory getting used more, so it's a RAM heavy work, then you go for the memory optimize. Suppose you are using the storage, or you are going to use the compute for the like your whatever storing document, retrieving things, those kind of cases where this storage is matters, the read write speed matters. Those cases you should go for the storage optimized instances, where it will be performance will be much better than this other type of instances, like database kind of instance you have to do. Then you go for the storage optimized one, where you need the read write happen to be very fast, the performance has to be very, like IOPs in general has to be very fast, where it makes sense. Then the accelerate computer high performance. Suppose as an example that match day of this this Hotstar goes on, where millions of people watch it. There's humongous things going on. There is a lot of traffic, lot of workload, lot of processing going. Then it makes sense to use this kind of an accelerated compute. And you cannot get an accelerated compute like I want it, I go it. No, you have to make a formal support request to any cloud before you can go for and use the accelerated compute. You don't have direct access. Nobody have direct access to it. You have to make a formal request or maybe a contract with the cloud service provider. Then you will assign this kind of accelerated compute. Otherwise, they will not give you this kind of accelerated compute. Okay, that is very important. Then what? So again, the block storage is actually both SSD and HDD, as I say. Okay, one very good question. It's a big one, so I will first organize properly. Let me make it small, make it big. Let's go. Let me go to the very last slide. So the question is that does it make sense? Does it make sense to keep our photos file moved to S3, which charges less, so we pay less compared to what we pay to Apple, Google? Specify specifically for the photos, video that had access less, but then you still need. Yes. So suppose, and that's actually make more sense, because in if you see, you have to see the cost parameter. If you are going to store your photos, file content, you may be access very less, but you need, when you need it, you want to pull it. Yes, you should go and use this S3 or maybe Google Blob, Azure Blob storage, Google storage, where it's mostly cheaper than this kind of cloud service and this storage service provider like Google Drive, for example, or Apple Cloud. You have to look at the cost. So for a month, how much Apple or maybe Google charging for normal storage, and if you store in a blob or object storage, how much is charging. Okay, you have to see the cost, but most cases it's less. It's less in this kind of cloud storage. For example, S3, if you store there as a even more, it will be cost me more less if you use infrequent access zone, or if you use this glacier storage, then it will be far less. So yes, that makes sense. uh, so are you sharing this PPT? Yes, I will share this PPT on Monday, tomorrow. Okay, some edit I have to do, then I will share it to you guys. Okay. One question: storage optimized CPU or IO optimized versus IO optimized volume. Now this is a very kind of question you might get in interview also. So IO optimized volume, say IO, I2, those kind of things where you have this block storage. Okay, that's our program, like they have the higher IOPs, but CPU is kind of processing all the stuff, right? So of course the IOPS matters in the when writing this kind of block storage. How much IOPS you have, that define how fast you can read write. But is the CPU can do all this, like ultimately what happening? CPU is processing it. How fast a CPU can process the instruction to all this read write storage? So if a CPU is programmed or is designed that way to for the storage kind of activity, it is programmed to do read write very faster, retrieving, like kind of read writing instruction, or maybe querying a bit faster. Those kinds of CPU, that makes sense. So suppose you are creating a database engine or database service for your application. Both matters. It's good to use a CPU optimized for storage, retrieval and writing and those kind of operation, and IOPS is higher, that will make entire thing faster. Of course, general CPU works generally as a common CPU, like general purpose. It do lot of stuff, storage, processing, string, instruction, processing, other stuff. And but this kind of processor, when it's storage optimized, that means it's programmed that way. It will be faster than the normal or general purpose CPU. Now, the difference is actually very less until unless you are processing millions of records or millions of data. Then it will make sense. In normal cases, it will be kind of same, not much difference. Okay. So what is the difference between code deploy and code build? So code deploy is more of a when you're deploying the code to different cloud services, like different services. Maybe you're deploying to EC2, deploying to ECS, deploying to say Kubernetes. So those cases is the code deploy. Code build, when you have suppose you have your normal code, but there you need the code to have different modules. You need to install modules, you need to generate binaries. There where come the code build, it generate the runnable programs. So it can, like, it is deployment ready. The code deploy is deploying stuff to different machine, but it has to be deploy ready. If it need pre-processing or other stuff, you do in the code build, make it runnable, then you deploy via code deploy, then it will run. Okay, that's the main difference. Then it's done. This Nandi is saying that your paid course is div with free one, or is completely same. The same is div paid. Okay, yeah, content wise is same, but see, the suppose in the paid one you have the one-to-one mentorship. Someone need my help, they can book one-to-one session. We're going to discuss on topics or say particular problem they are facing one-to-one. But for the free one, I cannot do for thousands of people. Like, I cannot have that. I cannot schedule that kind of session. But for the paid one, they have one-to-one mentorship. Of course, they have any queries, they have more time. I will explain more depth. That's the main difference. It's of the focus they're getting is more than the free one. That's what the main difference is. Content wise, more or less same. Everyone know that part. Okay. Difference between VM and clicks UEROPS. Ultimately, Citrix. Let me check first what the Citrix you're talking about. Citrix. Let me check the Citrix part. Okay, Citrix is all-in-one workspace solution. What is that? Citrix Workspace software delivers business technology. Okay, okay, it's kind of virtual environment. See, virtual machines are machines where you can going to run your workload, more of application programming, application running, or or deployment targets, okay, where you run your application, do a lot of processing stuff. And this kind of Citrix are more of a all-in-all solution. You manage all this stuff and everything. Like maybe you're doing virtually a lot of stuff. That's use cases bit different. It's not designed to be kind of a virtual. Maybe there is virtual machine also running in Citrix. I never use it, so it's very hard for me to tell. But virtual machine in general, where you run your workload, you do run application, do a lot of file processing, other kind of processing, media processing, do all the stuff. That's fundamentally a bit different. Difference between VM, okay. So virtual CPU comes from one VM or different VM. If you have one VM, and see what is VM? VM means virtual machine. I mean, you when you select a VM, you specify how much CPU and RAM you need, how much virtual CPU and RAM you need, and you like after you select for a VM how much RAM and CPU need, then once you create start instance and create the instance, then the virtual machine get created. So the CPU is coming from, of course, the physical CPU underlying below the below the hypervisor. But how much you define you want to use, you can have only access to that. If you need more processing power, of course you can upgrade current instance or current virtual machine, or you can simply hire another VM, or you can create new VM where you can run your other stuff. Okay, that's based on that. There's the main differences. So different VMs means different virtual CPU, different hardware altogether. Not hardware, different virtual resources altogether. Okay. One question is Nilesh Goel, how is the geo replication handled? So every cloud have this own architecture, own point of view of handling this kind of geo replication, but they suppose you writing one stuff, okay, they have their softwares, okay, that replicate all over the globe if you are going for the multi-region solution, because the moment you say you want the global replication to happen, that means you are paying for it. Okay, I think one of the good example is the CloudFront. You are paying for the CloudFront, right? Now CloudFront is what? It's kind of a global cache, okay? Where suppose you upload your file or content, you specify maybe one say S3, you want the content or site or maybe anything that you have your content. Then one user when requesting, say the content actually stored in the US. I'm in Kolkata. I want to use one particular content. Then first time when I'm making the request, it will go to US, but the time will be faster. But since I requested the content once from Kolkata to US, then in Kolkata, if they have data centers or edge locations in general, there the cache will get stored. Next time I make request, it will not go to the US location, it will go to the Kolkata location, and that way entire process becoming faster. Okay. Lot of questions. Good. Questions are good. Feel free to ask any question you have, and of course this recording will have available in my YouTube channel. Stay there forever whenever you want to use it. And this concept, actually the concept that I have shown today, for example, quickly adjust it. Okay. So this one that I've shown today, for example, let me go back to the cloud computing concept, CPU and RAM, I think you guys already know. But this VM concept very important, because when you're running or you're going to run go to any cloud in general, there first if you want to run any application, you have to create a VM or you have to run an instance. Okay, that instance or that compute instance, whatever you call it, that actually is a virtual machine. So go to any cloud, you want to run something, you have to select a virtual machine. Now that virtual machine, how it's running is very important to know, that there is some software called Hypervisor that is running this kind of guest instance or virtual machines. And whenever you are selecting the CPU and all that, then you have to like that virtual CPU, there is a rule for virtual CPUs to play. Like you are selecting CPU, that means you are selecting virtual CPUs. How much CPU you need, how is the calculation happening, that you have to also look at in this particular slide. So that's why everything is important. One question is here, So total duration of the course that will teach projects with monitoring, any interviews. Yes, everything involved in the paid and free. See, the paid one is going to be more one-to-one interaction will be higher. More they will get personal approach. Free one is by only YouTube channel. Just like you're commenting, I'm giving answers that way. Oh, I think Hitesh Harikesh saying that Citrix is also a virtualization platform just like VMware. Oh, okay. Then yes, then VMware is a virtual machine like solution where you can create virtual machines. If Citrix is like that, of course, is also it's just like another virtualization tool you have, just like VMware. Thank you, Hitesh. Uh, It's Bhavesh saying then what is your streaming setup for YouTube Live? So streaming setup is actually pretty normal. It's the Sony A600 camera. We have Camlink data card, 1 Gbps internet. I think yeah, that's and of course this is one MacBook. I think latest 2021 MacBook with M1 Max chip. That's how the things are. And here this is all the Max version in this laptop. So yeah. No, you mainly need a camera. We need maybe this kind of you need a very good mic and pretty good laptop to process all this speeds and everything. That's it. Okay, anyone have any questions related to things that we covered? Mainly virtual machines, the compute part, virtual CPUs, type of instances. Then we covered the storage types. Feel free to let me know. I am here for more 10 minutes, for example. It's already 1:36. Still 10 minutes. I'm still here. Storage. This one. One confusion many people have is actually the storage part. Like we should go for the this SSD or hard drives. But I think now it's much more clear. I know IOPs part is also clear because these things we are learning here. We're going to we're going to utilize this concept in my cloud session and other places also, of course. Do you use StreamYard? So yeah, we use StreamYard, but StreamYard don't have this flexibility. So I use the Ecamm Live software. Okay. Okay. Looks like there is no further question. But if anyone have any questions, do let me know via LinkedIn, via maybe other places. Feel free to let me know. And yeah, then we can end our session here. Hope you guys like the session, the content. If anyone have any feedback, do feel free to let me know. I'll definitely work on that. Thank you. And yeah, this session entirely, it will be live section of my YouTube channel. So you can go and watch anywhere, watch anytime. And this playlist also I've created. Maybe I will add the playlist in the the description section so that next time it is an 8-month long kind of training plan, starting with basic of the compute, then compute and storage. Then we have next week I think networking and security part. Then the third week we have I think the Linux part. Then fourth week we have the this shell scripting. So everything important. If these things all you are learning today going to be the basic building blocks for your next complex stuff. Like when you call the programming, then you see I'm doing running a lot of commands and all that. So if you like, I'm using Linux systems. So everything you'll see when covering cloud, you will see we're using the virtual machines a lot. So if you don't understand the virtual machine basics, it will be hard. Now you understand what the virtual machine is, right? So these things matter. Again, thank you. I see even today is Sunday, so many people are live, which is kind of, I'm happy that everyone serious about learning all this stuff from the basics are live and learn a lot. Again, do let me know if you have any confusion at any point. I'll make it more clear. Okay. Thank you, guys. Thank you and thank you to everyone who is joined the session. If you haven't subscribed, do subscribe the channel. And yeah, like if you're not connected with my LinkedIn, do feel free to connect with my LinkedIn and share your feedback there. Bye.